In this lesson, we will be dealing with radical operations. At the end of the lesson, you should be able to perform operations on radical expressions with square roots, including addition, subtraction, multiplication, and division. So when you're adding and subtracting radicals, first thing you want to do is simplify them. And then you've got to have like radicals. So that's not really a technical term, but it's kind of like terms. And we add or subtract the numbers in front of the radical sign. And remember, our fractions, like always, must have common denominators. So when we talk about like terms, we say 2c plus 7c equals 9c. So we'd have the same thing where 2 square root 11 plus 7 square root 11 equals 9 square root 11. When we're multiplying radicals, again, start by simplifying. Multiply the numbers under the radical sign. For example, square root of 2 times the square root of 3 equals the square root of 6. Multiply the numbers outside the radical sign. So if I have 4 square root 2 times 5 square root 3, I multiply the 4 and 5, and that's 20, and I multiply the 2 and 3 and get 6. When we multiply variables, remember that we add the exponents. So 4 square root 2a times 5 square root 3a squared, 4 times 5 is 20, 2 times 3 is 6, and a times a squared is a to the third. When we're dividing, it's called something called rationalize the denominator. Remember we said if it's in simplest form, you cannot have a radical as a denominator. So when we rationalize it, it means that the bottom number, the denominator, has to be a rational number. So we multiply everything by the denominator, kind of like we did when we were clearing fractions, and remember to simplify the fractions. So for example, if I have 4 divided by the square root of 2, I have to multiply the top and the bottom by the square root of 2. So on the top I get 4 square root 2, and the bottom I get square root of 4. So on the top I still get 4 square root 2, but the square root of 4 is 2. So now I have a rational number as a denominator, and then I'm going to simplify the 4 and 2, and I'll get 2 square root 2. All right, so adding and subtracting radical expressions. So 3 square root 2 plus 7 square root 2 minus 6 square root 2 is 4 square root 2. The next one, we're just looking, we have to combine like terms. So these two are the same. So that becomes 8 square root 3. And these two are the same. So minus 2 square root 2. In C, we want to simplify those radicals first. So the square root of 80 is 4 square root 5. It's 16 times 5. The square root of 20 is 2 square root 5. And the square root of 80 becomes 6 square root 5. And so if I add those together, I get 8 square root 5. All right, multiplying them. So in the first one, 2 square root 3 times the square root of 21. It's kind of an invisible 1 there, right? So 2 square root 63. And I know that becomes 2 times the square root of 9 times the square root of 7. So that is 2 times 3 times the square root of 7, which becomes 6 square root 7. In the second one, the square root of 25 is 5. Square root of 36 is 6. So my answer is 30. You could definitely multiply 25 times 36. And whatever that is, it's going to be a perfect square. In C, I multiply the inside, so I get the square root of 15. And then a times a squared is a to the third. But that's not in its simplest form because I have that a to the third. So that breaks down to a squared and a. So it's going to be a square root 15a. For D, I have 4xy squared. So I'm going to simplify that right away and put it 2y times x. And this one, I'm going to simplify this one, and I'm going to say x times 6y. Then when I multiply it, I get 2xy times the square root of 6xy. Okay, this one we're going to use our distributive property. So 2 times the square root of 8 is the square root of 16. Square root of 2 times 4 square root 3. So we add 4 square root 6. The square root of 16 becomes 4 plus 4 square root 6. We cannot put those together and call it 8 square root 6. That would kind of be like us saying 4 plus 4a equals 8a. And we know that's not true. In the second one, we're foiling. So 4 times 3 is 12. We're doing double distributive property. 4 times the square root of 5 is 4 square root 5. Insides 3 square root 5. And then we've got the square root of 5 times the square root of 5, which is the square root of 25. So combining like terms, 12, and these are like terms, plus 7 square root 5, and then the square root of 25 is 5, and then we add these together and get 17 plus 7 square root 5. Dividing radicals. So again, make sure that you can simplify. If you can simplify, to do that first. So this one just becomes the square root of 49 over the square root of 81, which is 7/9. In the second one, I see that these can be simplified first. So I'm going to take the square root of 9x to the 4th over 100. Then I separate them, 9x to the 4th over the square root of 100. So that is 3x squared over 10. And this one, these can be simplified. So I get the square root of 28 over s squared, because when you divide, you subtract. I'll split that up and get the square root of 28 over the square root of s squared. Break this down to the square root of 4 times the square root of 7 over the square root of s squared. So that's 2 square root 7 over s. So the number under the radical sign is called a radicand. And to rationalize the denominator, multiply by your least common denominator or your radical.